Important questions for 2 marks binomial theorem. Question number 1. Find the number of terms in the expansion of 2x plus 3y plus z whole to the power of 7. Solution. Number of terms in a plus b plus c whole to the power of n are n plus 1 into n plus 2 by 2 where n is a positive integer. This question is in this form. Okay. A plus b plus c whole to the power of n. So n is equals to 7. So the number of terms will be n plus 1 into n plus 2 by 2. N is nothing but 7. 7 plus 1, 7 plus 2 by 2. 7 plus 1 is 8 and 7 plus 2 is 9. 8 into 9 is 72 by 2. 2 ones are 2, 3s are 6. 1 left, 2 6 are 12. So 36 is the answer. Question number 2. Find the number of terms in the expansion 3a by 4 plus b by 2 whole to the power of 9. Number of terms in x plus a whole to the power of n is n plus 1. One number will be extra always. If the n is there, so n plus 1. If 9 is there, so 10 will be there. So where n is the positive integer. Hence, the number of terms in 3a by 4 plus b by 2 whole to the power of 9 is 9 plus 1, which is 10. Okay. For 3 terms, the formula is this. For 2 terms, the formula is n plus 1. Okay. Question number 3. Find the set of value of x for which the binomial expansion of 3 minus 4x whole to the power of 3 by 4 is valid. Okay, we have to find the set of values of x and the binomial expansion is 3 minus 4x whole to the power of 3 by 4. This one. Here we will make this question in the form of 1 minus x. Okay, to get 1 here we are taking 3 common from this 3. So it will be 1 here minus here 3 is not there, so 3 will come in the denominator. Okay, whole to the power of 3 by 4. As we are taking 3 from this, so the power will also goes here. 3 to the power 3 by 4. This one 1 minus 4x by 3 whole to the power of 3 by 4. Okay. Now the binomial expansion of 3 minus 4x whole to the power of 3 by 4 is valid when this term, that is x value 1 minus x form it is. So this value mod 4x by 3 less than 1. Now we want only x value. So take this 3 here. It will be multiplied here 3 and this 4 will be multiplied in the denominator. So 3 by 4 mod x is less than 3 by 4. Therefore, the values of x is minus 3 by 4 comma 3 by 4. Okay. Question number 4. If 22CR is the largest binomial coefficient in the expansion of 1 plus x to the power of 22, then find the value of 13CR. Okay. Solution here n is equals to 22 and it is even number. Okay, so therefore the largest binomial coefficient is n c n by 2. N is 22, c n by 2 means 22 by 2 which is equals to 11. Okay, largest binomial coefficient is n c n by 2. It's a formula. Okay, so n c, this one will be r, so r is equals to 11. We want the value of 13CR, that is 13CR value is 11. NCR formula is nothing but n factorial by n minus r factorial into r factorial. 13 factorial by 13 minus 11 is 2, 2 factorial and 11 factorial. Okay, 13 factorial can be written as 13 into 12 into 11 factorial by 2 factorial into 11 factorial. As there is 11 factorial is in denominator, so I am writing till 11 factorial only so that I can cancel this. Okay, here in the numerator 13 into 12, denominator 2 factorial means 2 into 1, that is 2. Okay, 2 ones are 2 6 are, so 13 into 6 which is equal to 78. Therefore 13C11 is 78. Okay. Question number 5. Find the sixth term in the expansion 2x by 3 plus 3y by 2 whole to the power of 9. We want sixth term, that is T6. We can write it as TR plus 1, that is T5 plus 1, that is equals to 6. So we know the formula for TR plus 1 is NCR x to the power of n minus r a to the power of r. This is n. Okay, so r is r plus 1. So this is r. R is equals to 5. N is equals to 9. X is equal to 2x by 3. And a is equals to 3y by 2. Okay, substituting all this value in this formula, that is t 5 plus 1. N is 9, C 5, and X is 2x by 3 whole to the power of n minus r, that is 9 minus 5. A is 3y by 2 whole to the power of r is 5. 9C5, 9 minus 5 is 4. So 2 power 4, x power 4 and 3 power 4, giving power separately into 3 power 5, y power 5 by 2 power 5. Okay. 9C5, x power 4, this 2 power 5 and 2 power 4 gets cancelled. You will left with 2 power 2, 1 2 in the denominator. And here 3 power 4 and 3 power 5. So 3 power 4 and 1 3 will be left here in the numerator. And this one same as it is. Okay, 9C5 into 3 by 2, x power 4, y power 5. Now we have to find 9C5. 9C5 is in the form of NCR. NCR is nothing but n factorial by n minus r factorial r factorial. N is nothing but 9 factorial by 9 minus 5 factorial 5 factorial. 9 factorial same as it is 9 minus 5 is 4 factorial and 5 factorial. 9 factorial can be written as 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Similarly, 4 factorial can be written as 4 into 3 into 2 into 1. 5 can be written as 5 into 4 into 3 into. This 5 from this to this will get cancelled. Now 4 ones are 4 twos are 3 ones are 3 threes are and 2 gets cancelled. Okay, 2 threes are 6. Okay, now multiply all these terms. 3 into 2 into 7 into 3. You will get 126 here. 2 ones are 2, 6 are 12, 2 threes are. Now multiply these two. You will get 189, x power 4, y power 5, same as it is the answer. Number 6. Prove that C0 plus 2C1 plus 4C2 plus 8C3 plus so on up to 2 to the power of n Cn whole is equals to 3 power n. Okay. Solution. We know the formula 1 plus x whole to the power of n is equals to nc0, which is nothing but c0 also. Okay. nc1 we can write it as c1x plus nc2 can be written as c2x square plus c3x cube so on up to cn x power n. Here 2 is there, so n. Okay, put x is equals to 2 in this equation. 1 plus 2 whole to the power of n is equal to c0 c1 into 2 plus c2 into 2 square plus c3 into 2 cube. So here 2 to the power of n. Okay, at the place of x we are writing 2. So 1 plus 2 is nothing but 3. 3 to the power of n is equal to c0 plus 2c1 plus 2 square is 4c2 plus next term will be 2 cube, that is 8c3 plus so on up to 2 to the power n cn. Hence proved. Okay, just we are putting x is equals to in the equation. This is the formula. Number 7. Find the middle term in the expansion of 3x by 7 minus 2y whole to the power of 10. Solution. The number of terms in the expansion of 3x by 7 minus 2y whole to the power of 10 is 11. Okay, here 10 is there. So the number of terms will be 1 extra, that is 11. So 11 term means 6th term will be the middle term. In 11 terms, 6th term will be the middle term. So we want t6th value. We can write it as t5 plus 1. As we know the formula of tr plus 1. Okay, so we're writing 6 as 5 plus 1. So r is 5, n is 10, a is this and x is this. Okay, 10c5 ncr x to the power of n minus r to the power of r. Okay, substituting the values here. 10c5 3x by 7, 10 minus 5 is 5 minus 2y to the power of 5. 10c5 giving power separately, 3 to the power of 5, x to the power of 5, 7 to the power of 5, minus 2 to the power of 5, y to the power of 5. Okay, this minus multiply here, minus 10c5, 3 into 2 whole to the power of 5. Here power 5 is there, here also power 5, so we are multiplying 3 into 2, that is 6, 6 power 5, x power 5, y power 5 same as it, and 7 5. So this is the answer. Question number 8. Find the 8th term of 1 minus 5x by 2 whole power of minus 3 by 5. Okay, the power is minus here, so we have to consider the formula of 1 minus x whole to the power of minus p by q. Okay, comparing this with this, so we get x is equals to 5x by 2. At the place of x we have 5x by 2. Okay, at the place of p we have 3. At the place of q we have 5. Okay, now we want x by q. X value is 5x by 2 by q value is 5. So this 5 gets cancelled. You will get x by 2. X by q is nothing but x by 2. Now the formula general term in this is tr plus 1 is equals to p into p plus q, p plus 2q, so on up to p r minus 1 into q upon r factorial x by q whole to the power of r is the formula for general term of this expansion. Okay, so now just we are substituting the values of p, q, x by q, x. After substituting all the values, we get 3 into 3 plus 5, 3 plus 2 into 5, so on, 3 plus 7 minus 1 into 5, x by 2 whole to the power of 7 by 7 factorial. Okay, 3 plus 5 is 8, 3 plus 2 into 5 is 10, 10 plus 3 is 13, 13. Okay, here difference of 5 is there. 3 plus 5 is 8, 8 plus 5 is 15, 15 plus 5 is 18, 18 plus 5 is 23, 23 plus 5 is 28. So this one is 33. So we are writing the series like this one same as it is and 7 factorial same as it is. You can keep it till here or you can simplify. Simplify means like write 7 factorial, that is 7 into 6 into 4 into 3 into 1, then cancel it. You will get 118,404 by 5 x by 2 whole to the power of 7, or else you can do till here also. Okay, and find the set E of the value of x for which the binomial expansion 2 plus 5x whole to the power of minus 1 by 2. We want set E value of x. Okay, 2 plus 5x whole to the power of minus 1 by 2. Okay, first we will convert this in the form of 1 plus x. So to get 1 here, we have to take this 2 common. So taking 2 common, so here 1 will be there, plus here there is no 2, so it will be divided 5 by 2 into x whole to the power of minus 1 by 2. Okay, as we are taking 2 from this bracket, so this 2 will also get the power minus 1 by 2. Okay, the binomial expansion of 2 plus 5x whole to the power of minus 1 by 2 is valid when this value is less than 1. Mod of this value 5x by 2 is less than 1. Cross multiply x less than 2 and this 5 multiply here 2 by 5. So the values are nothing but minus 2 by 5 or 2 by 5. Question number 10. If 1 plus x square whole to the power of n is equals to alpha 0 plus alpha 1x plus alpha 2x square plus so on alpha 2x x to the power of 2n, then prove that alpha 0 plus alpha 1 plus alpha 2 plus so on alpha 2n is equals to 3 power n. See, directly we can see from here, if we put x is equals to 1, 1 plus 1 plus 1 will be 3 to the power of n. We got this. If we substitute here also 1 1 1, so you will get alpha naught, alpha 1, alpha 2, alpha 2 x to the power of 2n. So this is 2n x to the power of 2n. Okay, given 1 plus x square whole to the power of n is equals to a naught, or else you can write alpha naught, as question is alpha, so you write alpha naught alpha 1 x plus alpha 2 x square plus so on alpha 2n x to the power of 2n. Okay, put x is equals to 1. 1 plus 1 square is nothing but 1 whole to the power of n is equals to a0. a1 into 1 is a1 plus a2 into 1 square is 1, that is 1 into a2 is a2 plus 1 to the power of something is 1 only. Okay, so a to the power of 2n, sorry, a 2n, base 2n. So 3 power n, 3 power n is equals to a naught plus a1 plus a2 so on up to a to n, or you can write 3 to the power of n is equals to alpha naught plus alpha 1 plus alpha 2 so on alpha to n, as our question is in terms of alpha, so write in alpha. Question number 11. If a and b are the coefficient of x power n in the expansion of 1 plus x whole to the power of 2n and 1 plus x whole to the power of 2n minus 1 respectively, then find the value of a by b. A and b are nothing but coefficient of x power n in this n in this expansion. Okay, this is for A and this is for B. First we will expand these two, then we'll see for coefficient of x power n. Okay, 1 plus x whole to the power of 2n will be nc0. N is nothing but 2n, so 2nc0 plus 2nc1 x power 1, 2nc2 x power 2 plus 2ncn x power n. See here 2 is there, so 2. Here 1 is there, so 1. So if there is n, so here n will be there. So if here 2n is there, so 2n. As the number is ending with 2n, so we have to write till 2n whole to the power of 2nx. Okay, therefore the coefficient of x power n is 2n cn, 2n cn. Okay, which is nothing but a. As in the question it has given a and b are the coefficient of x power n, so a is equals to 2n cn. Okay, for b, taking the second expansion, that is 1 plus x whole to the power of 2n minus 1. So n, this is n, nc0, 2n minus 1 c0, 2n minus 1 c1x plus 2n minus 1 c2x square. Similarly here 2 is there, here n will come. 2n minus 1 c n x power n plus so on 2n minus 1 c 2n minus 1 x to the power of 2n minus 1. Okay, the coefficient of x power n is, x power n coefficient is this one, 2n minus 1 cn. So b value is 2n minus 1 cn. Now we have to find a by b. A is equals to 2n cn, b is 2n minus 1 cn. 2n cn means it is in the form of ncr, n factorial by n minus r factorial by r factorial. This is r and this is n. So at the place of n we are writing 2n, at the place of r we are writing n. Okay, n factorial by 2n minus r, that is n factorial, n factorial by, here also ncr, n factorial, 2n minus 1 factorial, and n minus r factorial, 2n minus 1 minus n factorial, and r factorial is n factorial. Okay, now reciprocal, 2n factorial by n factorial into n minus 1 into n factorial, 2n minus 1 factorial. Okay, see here 2n minus n is nothing but n. Here also 2n minus n is n minus 1, n factorial. Okay, reciprocal, 2n factorial can be written as 2n into 2n minus 1. Okay, because whenever we do the factorial, one number will be less. So 2n minus 1, 2n minus 2. Okay, we are writing till 2n minus 1 factorial because we can cancel here these two. So for this we are writing 2n minus 1 factorial. For this same as it is, and this one also same. Here n factorial same as it is, and this n factorial can be written as n into n minus 1 into n minus 2, but we are writing till n minus 1 factorial so that we can cancel here. Okay, so n minus 1 factorial, n minus 1 factorial, and this n factorial and this n factorial, this factorial and this factorial get cancelled. 2n by n, and n gets cancelled. 2 a by b is equals to 2 is the answer. Question number 12. Find the term independent of x in the expansion 4x cubed plus 7 by x square whole to the power of 14 is the question. We have to find the term which is independent of x. Okay, so we are using general term formula here, that is tr plus 1 is equals to ncr x to the power of n minus r a to the power of r. Okay, x is nothing but this term, a is this term, n is 14. Okay, so ncr 14cr r same as it is 4x cubed, that is x this one, and a this one whole to the power of n minus r, 14 minus r whole to the power of r. Okay, 14cr separately giving powers, 4 to the power of 14 minus r, x cubed to the power of 14 minus r, 7 to the power of r, this is r. Okay, and taking this x square to the numerator, so this power will become minus x to the power of minus 2 whole to the power of r. Okay, 14cr 4 to the power of 14 minus r, 7 to the power of r, and these bases are same, power should be added. So 3 into 14 is 42 minus 3 into r into x to the power of minus 2r. Now add these powers, x to the power of 42 minus 3r minus 2r. Okay, minus 3r minus 2r is nothing but minus 5r. This one same as it is. Now we have to find the term which is independent of x. It means there is no x term should be there. So for this we have to equate this value, the power of x, to be equal to 0. to get r value. After getting the r value, we will substitute here. You will get the answer if the r value is positive integer. For term independent of x, put 42 minus 5r is equals to 0, 42 is equals to 5r, r is equals to 42 by 5, which is not an integer. Hence, the term independent of x in the given expansion is 0. There is no term which is independent of x. Every term has x term. Okay.